Assalamu alaikum wa rahmatullahi wa barakatuh. So this is going to be the second last video in our probability series, right? And then we are going to move on to newer topics, right? So the topic for today is under the probability topic. The subtopic is probability distribution tables, right? Now look, a probability distribution table is any table that you use to represent the individual probabilities or the individual events probabilities inside a parent scenario, right? Alhamdulillah. And also, rather than just saying random stuff, shooting bullets in the air, it would be better if I was to just show you. So I do have a scenario right here in front of me, and first of all, we're going to try to find all the probabilities, just like we would have done had we not been learning about probability distribution tables. No, no. So Amanda rolls two four-sided fair dice at the same time. You would see that in the examination questions, right? Four-sided fair die, right? Now the result is going to be the greater of the two stores, of the two scores on both of the die, right? And if obviously both of them are same, the result is going to be zero. This is the scenario we have. So how do we find the probability for each of them? Now look, obviously we find the probabilities using what? Is a simple table, and this is how you make a simple table. First dice, second dice, right? Mm, okay. Now look, one, two, three, four, and one, two, three, four. Now look, again, same. I'm not going to be explaining what I'm doing right now in a simple table. The reason being we've already done it over here. Look, simple tables. We just did that in the last lecture, right? So I'm not going to explain much what I'm doing right now because this is not the topic. If you really want to know what is a simple table and how do you solve these kinds of scenarios, do check out the previous video, my channel, for that. Now look, the greater of the scores is over here, it's 2, 3, and 4. Over here again, it's 3 and 4, and again, that's a 4 over here. Over here, that's a 4, and a 4. That would be a 3 and a 3, and that would be, wait, yep, that would be a 2, right? I hope I did it right. So, now, look, there are four of them over here, and there are four of them over here, right? So the total outcomes or our denominator would be, sorry, four, never mind. Oh, my pen just fell. Four, a 4 times 4, and that would be 16. Okay. Now, what is a probability distribution table? Like I said, this is how you make a probability distribution table. X, right? And the probability of X. This is how you make the table. Now, X is something we call the random variable, and this denotes a number, right? Like, for example, if I write it this way, or if the probability distribution table has been given to you this way, or they ask you to make it, this is how you do it. You take a look at all of the numbers that you have inside your outcomes, and you write them this way. We don't have a 1, but we do have a 0. So 0, 2, 3, and 4, right? We don't have a 1 in here. Now we're going to write the individual. So, on the upper side of the table, you write all of your outcomes, and then the probability, and then you write, the probability of their occurring, right? So look, this is how you do it. Again, it's all going to be out of 16 because the probability. How many times does 0 appear? 4, right? How many times does 0 appear? 2. How many times does 3 appear? 4. And 4 itself appears 6 times, right? This is how you write up. This is how you make probability distribution tables. Ooh. Just give me a second, guys. Right. So look, this is a probability distribution table. So X denotes, or the random variable just denotes a number, right? And then the occurrence for that number, or the occurrence for that individual events, we just keep on writing the probabilities for each event. It doesn't mean that the question is always going to be about these simple tables, and then from that they're going to ask you to make a probability distribution table. The question can be anything. It can be about it can be about picking balls from a bag. It can be about flipping coins or flipping multiple coins at the same time. You don't always have to make a table. It's just that, this is just how we had to do it in this scenario. Like I said, I do give you the main concept, but what really matters is past paper practice, because that tells you the all the slightest things that you might not learn inside a classroom, and the nuances that you learn in the past papers, right? You don't learn that in class, right? But the main concepts, obviously, you are going to learn in here. Once we dive into the past paper practice, it's just going to become easy, right? But for now, you do have to, if for this scenario, you do have to make this table, right? So this is how we make it. It's just this simple. This X is called the random variable. These numbers that we have in here are just these are just numbers, or these are just occurrences, and then we need to write the occurrences of those events, right? Or in other words, the probability. Think of it like, when you have in the simple data representation, you've got simple things like these, right? Like, for example, data was collected from 15 athletes, right? So some of them were 10 meters. Their jumps were 10 meters. Some of them had 20-meter jumps. Some of them had 15-meter jumps. Now, how many of them had 10-meter jumps? 20 of them, 30 of them, or 60 of the athletes. I said 15. Let's say more. Okay, 60 of the athletes from the total data had 15 meter of long jumps, right? That would be the frequency. This is exactly what we're doing in here. It's just that, we are writing it sorry. It's just that we are writing it in the probability kind of form, right? This is why these numbers are the occurrences, and the probability of these occurrences, the individual probability of these occurrences appear down there, right? Now, there's something, a property that you must know about this part of the table. You see this part. The sum of this is always going to be equal to 1. Okay? The sum for this is always going to be equal to 1. So sometimes, now look, once you know the concept, the question can ask you anything. They might ask you to make a probability distribution table, just like we did in here, or they could have given you the scenario. Alhamdulillah, they could have given you the table as well, and they could have just said this X. This could have been a question. They wouldn't ask you, let's say they didn't ask you to make the table. They instead gave you the data, but this one probability was missing. How would you find that probability? You know that this entire thing is equal to 1, right? So what would you do? You write 4 over 16 plus 2 over 16 plus 6 over 16 plus X is equal to 1. Right? And you would easily find yourself the answer, and that is, how much? 1, 2, 3, 4. That would be 4. That would be 4. It's just simple as that. Sorry, 4 over 16 it would be. So this is how you make a probability distribution table. That was the first part for this video. I'm going to make another part again for probability distribution tables, where we're going to talk about these things, right? And this, and what else do we call it? Yes, we have got, dude, what was it called? Expected value of x squared, and yes, the variance, what's a variance and what's standard deviation, these things, right? Or deviation, how may ever you want to pronounce it. These are the things that we are going to be doing in the next question, inshallah ta'ala. So for now, assalamu alaikum wa rahmatullahi wa barakatuh. I said next question, I meant next lecture, inshallah.